Today we'll just continue our topic for Stadia theory. Now recall, we answered up to number 3 last meeting. So now let's answer the last problem, which is example number 4. Okay. So number 4. In the figure, the difference in elevation between observed points A and B is 15 meters, and the horizontal between them is 35. With transit at station O, additional information was obtained as shown in the table. Determine the Stadia intervals at A and B. Assume K is 100 and C is 0. So first, let's start out with writing the given. Difference in elevation between A and B is 15. So let's call that DE for this difference in elevation for A and B, 15 meters. Next, horizontal distance between them, 35. So horizontal distance is H. So HAB, 35. Now I chose H instead of B because I know from the table that our observation is inclined because of the presence of these values. So this is your vertical collimation reading, 1210. So 35 meters. And then Stadia K equals 100, C is 0. Now let's determine what is being asked in this problem. We're looking for Stadia intervals. So Stadia reading or S. So looking at the table, that is also the unknown. So given station at A, observing points A and B, station at O, observing points A and B, these are your A and B. This is your rod reading or leveling staff reading, and then your angle. So we're looking for S. So to solve for this, we're going to use what's given. And what's given is your horizontal distance and your difference in elevation. Let's start with horizontal distance first. And then recall the equation for horizontal distance. That is Ks cosine alpha plus C cosine alpha. Okay. So H Ks cosine alpha plus C cosine alpha. Now C is 0, so that's just Ks cosine alpha times cosine alpha. So we can simplify our equation to Ks cosine squared alpha, right? And now let's use that equation and sub in what we know. So let's start first with horizontal distance from A. Okay, so HA equals Ks. K is the same, that's just 100. And then S, sight reading, let's call that SA, that's the unknown. And then cosine squared alpha, that's the angle for A. Looking here, that's 12 degrees. So cosine squared 12. Let's do the same for B. So HB equals, again, K is the same. It's a constant. That's still 100. And then sight reading at B. And then cosine squared. Let's get the vertical angle at B. That's 10 degrees. Okay. And then, remember, we have another given with regards to horizontal distance. And that's and distance between A and B is 35. To get distance between A and B, that's HA. Okay, looking here, right? That's HA. This is your HA minus HB. This is HB. That's how we get distance between A and B. Okay, so writing that in terms of equation, HA minus HB, and that's given as 35. And then let's sub in our equations for HA and AB and HB. So 100 SA cosine squared 12 minus HB, which is 100 SB cosine squared 10 equals 35. Let's simplify. You can use this on your own, or I'd like to simplify this further. I'm just going to divide everything by 100. Okay. So this will become SA cosine squared 12 minus SB cosine squared 10 equals 35 over 100. That's 0.35. Now, there's nothing to solve for this equation. That's two unknowns, okay? So that's fine. I can just leave that as is and use it later. So I'll just call that equation 1 for now. So now we've used this. HAB equals 35. Next, we're also given difference in elevation. So we can use that to get another equation relating SA and SB. And in order to do that, let's get equations for vertical distance now. So we're done with H. Now let's do V. So V equals, okay, recalling our equation, that's just K sine alpha plus C. But instead of cosine, this is now cosine. But instead of cosine, this is now sine alpha. And once again, C is 0. So this becomes K cosine alpha sine alpha. Now, can anyone tell me our double angle identity? Do you remember from your math classes what's the double angle identity for sine? Buuin nyo. The whole equation, blank equals blank. Okay, correct RDL and John. Lapid, vertical. So very good. You still remember some of your identities. And then to recall, so recall sine 2 theta equals 2 sine theta cosine theta. Therefore, sine theta cosine theta is equal to sine 2 theta over 2. So let's sub that here. The V is now sine 2 theta over 2 for this. So that will be 1/2 Ks sine 2 theta. Okay, so I did this just to make our equation easier or shorter, all right? So now let's sub. Let's start with VA. So VA is just 1/2 Ks. Again, K is constant, so that's 100 SA sine 2 times theta. This is alpha. Alpha for the first one is 12. Okay. Let's simplify this. VA, 1/2 of 100, that's 50 SA sine 24. Okay, now let's do the same for VB. VB equals 1/2 times 100 for K, again, because that's a constant. This is now SB sine 2 times 10. Once again, simplifying, VB equals 50 SB sine 20. Okay, so now I have the equations for VA and VB. I need to relate that to this distance in difference in elevation. Okay, I'll just move this first. All right. So difference in elevation between A and B is this. Okay, this is your difference in elevation. And then, or that's your 15. And then let's figure out what's VA and VB. Okay, so this is VA from your instrument. Okay, let's do this better. Okay. So let's say here's your instrument. This is VA. Okay. And then for VB, that's this. Okay. And so V is from instrument to reading. So this is your VA. And then for B, it's over here. So this is your VB. And the reading here. Now let's take into consideration the readings. This reading at A, let's check it out. That's 1.863. And that's this length, 1.863. And then this, the reading here, and just this, and that is 1.5. Okay. Sorry, that's not 1.5. It's from the ground. Okay, so and this is the 1.5. Okay, so readings are from the distance from the bottom of your level to the top. So that's your 1.5, this is your 1.86. Okay. Oh, from this drawing, can anybody give me an equation relating VA and VB? Correct, John. Who else? Anyone else? No, the exact equation. Kulang. What happened to 1.5? There is something incorrect about that equation. Very close though. Okay. Correct. Geraldine. Very good. Okay, so all of that is correct. Let's look at it this way. VA, VA, okay, minus 1.86, so I'll delete that, minus VB, so that's this, plus 1.5 equals 15. So that's the equation that I'll use. So VA, again, minus 1.863. So that minus this minus VB plus 1.5 plus 1.5. And that's equal to your difference in elevation, 15. Let's simplify this. So VA minus VB. So 15 plus 1.863 minus 1.5, that's 15.363. And then from this, you can sub in your VA and VB. Okay. Okay, so let's sub. VA is this 50 SA sine 24 minus 50 SB sine 20 equals 15. Okay, and once again, that's two unknowns, SA, SB, but I can just write that as an equation too. So now we have two equations, two unknowns. Please solve using simultaneous equations. What's SA? Let's start with SA first. Okay, so practice solving simultaneous equations. So 15.363. No. Okay, correct. Denzel. Anyone else got SA? No. Okay, correct, John. What about SB? So SA is 2.65. What about SB? Correct, Denzel. Who else? And Maro. Okay. So 2.26, correct. SB 2.26. Oh, meters. And that's the answer. So that's it for number 4. Do you have any questions? Please answer in the chat. Okay, no questions. So that's it for the problem solving part of this topic. Now, if you've noticed, I've uploaded a new lecture in your Blackboard, which is your errors in Stadia work or Stadia reading. So most of these are self-explanatory, but let's read them one by one. So first, many of the errors of Stadia are those common to all similar operations of measuring horizontal angles and differences in elevation. So the errors here may also be present in any activity that involves getting horizontal and vertical distances and angles. So sources of error in horizontal and vertical distances computed from observed Stadia intervals are as follows. So first, there's an error in the Stadia interval factor. So this condition produces a systematic error in distances, the error being proportional to the Stadia interval factor. The case is parallel to that of tapes, which is too long or too short. So remember, when tape is too long, you have to either add or subtract correction value. So same thing, if there's an error in Stadia interval factor, you have to make appropriate changes as well. So Stadia interval factor, that is your, let's review ourselves with the terms. So that's your K. If there's an error in K, all equations involving K, and as you can see here, will change as well. So your horizontal distance and vertical distance will change. The greater your stadia factor, the greater your h, and then therefore the greater the error. So that's why they're parallel with take too long or too short. The next type of error is rod is not of standard length. So if the spaces on the rod are uniformly too long or too short, a systematic error proportional to the stadia interval is produced in each distance. So recall, in your previous fieldworks, you've already seen what the gradation or division on a leveling staff is, or leveling rod. So if your rod is too short, and meaning the divisions will be inaccurate as well. So your readings will be inaccurate as a consequence to that. So errors from this source may be kept within narrow limits if the rod is standardized and corrections for erroneous length are applied to observed stadia intervals. For example, we also have corrections for when your tape is too long, too short, due to temperature sagging full. When we compute for those corrections, you can just add or subtract it to your reading. Same thing here. If your rod is too short or too long, you can just take its correction factor and apply it to your final readings. So except for stadia surveys of more than ordinary precision, errors from this source usually are of no consequence. And so in regular surveying work, your rod being too long or too short won't affect the outcome too much. Again, the exception is if your project requires exceptional precision. The third error is incorrect stadia interval. So the stadia interval varies randomly owing to the inability of the instrument operator to observe the stadia interval exactly. So now this is a human error, incorrect stadia interval, because getting the stadia interval is getting the reading or difference in readings between the highest and lowest crosshair. Okay? So the only way for you to mess this up, or one way for you to mess this up, is by incorrect reading. So human error is a factor here. And then in a series of connected observations, such as a traverse, the error may be expected to vary as the square root of the number of sites. So error is inversely proportional, is directly proportional to the number of sites squared. So for example, if you took site readings 5 times, then your error is directly proportional, or is equal to 5 squared, which is 25, or a percentage of that is your error. So this is the principal error affecting the precision of distances. It can be kept to a minimum by proper focusing to eliminate parallax, by taking observations at favorable times, and by care in observing. So again, this is done by the operator of your instrument. They take the readings manually if we're just using a directional or optical theodolite. And then it can be kept to a minimum by proper focusing using your focusing screws on your theodolite to eliminate parallax, which is your difference in vertical readings. And then taking observations at favorable times. So make sure the weather isn't that windy so that your rod isn't swaying too much, which causes inaccurate readings. And of course, rain also affects our line of sights. And of course, you have to take care in observing and don't rush it. And so parallax is displacement or difference in the apparent position of an object viewed along 2 different lines of sights. Number 4, error in verticality of staff. So this condition produces a perceptible error in measurement of large vertical angles than for small angles. So the larger your vertical angle is, the larger your error. It also produces an appreciable error in the observed stadia interval, so your S reading, and hence in computed distances. Because again, error in stadia interval and incorrect stadia interval also creates error in distances. Because again, looking at the equation here, S affects your horizontal and vertical distances. So it can be eliminated by using a staff level or like a plumb bob to make sure your staff is vertical. The fifth error is refraction. It's the unequal refraction of light rays in layers of air close to the Earth's surface affects the sight on the lower stadia hair more than the sight on the upper stadia hair and thus introduces systematic error in stadia measurements. Whenever atmospheric conditions are unfavorable, the sights should not be taken near the bottom of the rod. Okay, so this is an error due to weather. So unequal refraction of light rays, since we're using a telescope, refraction plays a role in what we actually see versus what is actually horizontal, or which is actually horizontal to the instrument. So if you remembered your physics class, you have your error due to refraction. We also discussed this earlier in our mean sea level discussion, which is your error due to the curvature and refraction of the Earth. So that affects your stadia readings as well. And the final error is error in zenith or vertical angles. So error in vertical angle is relatively unimportant in their effect upon horizontal distance if the angle is small, but it is perceptible if the vertical angle is large. So similar to what we have here in error in verticality of staff, if the angle is not large, then the error produced isn't that problematic. It becomes an issue when the angle that you're observing is large enough. And once again, this is a systematic error. So remember, systematic errors can be remedied by applying appropriate corrections. So that's it for errors in Stadia work. Once again, if you have any questions, please answer in the chat. Okay, great, no questions. So that means we're done with our topic. Okay. Right. So now, before I let you go, let's have a few reminders. So we're done with this, your topic number 8. So on Saturday, you'll have your assignment, therefore there's no Zoom meeting. So you already know what to do, right? We've had assignments before. So no meeting on Saturday. Also, field. We'll have field tomorrow, a short activity for our field tomorrow. So 12 o'clock onwards. So please attend the Zoom meeting tomorrow for our field meeting. And then next week, new topic, and then you'll have your quiz number 2 on Saturday next week. Okay? So that's it for the reminders. Also, don't forget to submit your preliminary data sheet for fieldwork 7. I believe that's what we have to do. Let me double check. Yep. And so deadline preliminary data sheet, I believe, is tomorrow, 11:59 p.m. Yep. Okay. Group report, the topics per group. Oh, there's no per group topics. Everyone has the same topic. It's construction surveys. So this is a broad topic. It's up to you how you want to divide every subtopics of construction surveys. So everyone has the same general topic. to you how specific or general you want it to be, and how much scope you want. And then this is your criteria: master the subject, presentation, and also you have to do your written report. So the grading of this is individual. Okay. But these two parts are individual. So you design your own PowerPoint. And of course, you have to study your own topic. But the written report is graded as a group. Okay, so compile all of your information in written form, computerized. Make sure it's presentable as well. And that's it for oral report. Any other questions? No more? Pero po, ang hatian ng topic ay group po. Yes. When you search for construction surveys, you'll see that there are a lot of types or a lot of topics under this. It's up to you as a group to divide it among your members. But each group has the same general topic, which is construction surveys. So some of you may overlap with the things that you say. Okay, so I'll just compare who explains it better. Which group explains or which member explains it better versus the members of other groups. Okay. So does that answer your question? Okay. Any other questions, clarifications, concerns? None. All right. Oh, by the way, I've also rechecked your modular exam. So that's done. So we're done now with module 1. Nothing left to recheck, right? The only thing I have to do now for module 1 is to create an activity for those who got an IP. So for those who got a failing grade in module 1, again, I will upload an activity on the weekends for you to answer. For those who got an IP because you missed answering some quizzes, SeatWorks, lesson, homework, okay, send me a letter on why you didn't answer it for a week. Because remember, all of our activities are available for a week. And so send me a letter with proof on why you weren't able to answer it for a week. Okay? Okay, so that's it for our topic for today. I'll see you tomorrow during our field meeting. Since you don't have any more questions, you may go. Goodbye, class.
Thank you po, ma'am.
Thank you po, ma'am.
Thank you po, ma'am.
Thank you, ma'am.
Thank you, sir.